Okay, so I made all of the materials for this project, and I made them in Material Maker. First one is the leaf texture, or the leaf material, and I made it out of some basic geometric shapes. And I lined them up, created this general shape of the leaf, and then I added the veins with some mirroring effects and some sine waves. Added a bunch of noise and some coloring. And I used the vein pattern as the height map, put that into a normal ambient occlusion and depth generator. The bark texture is just some basic Voronoi noise, and then I warped it. It's painting that to like a desaturated brown. And then I run that through the normal ambient occlusion and depth generator, just like before. So this is one of the rock textures. It uses a bunch of different Voronoi noise at random scales, and then it randomly selects only some of the cells to go through. The smaller that the cells are, like the smaller they are on the XY dimension, the smaller they are on the height dimension as well. And then here you can see them getting progressively added. I just paint the bigger rocks on top of the smaller rocks until we end up with this, which is the final output of all the rocks. And then I do two things. I up here, this is a mask of this image where black means that there are rocks, white means that there aren't any. That's used so that I can paint where there aren't any rocks a different texture than where there are rocks. Then down here, I'm lightening and darkening the rocks by just random Perlin noise, so that way it gives it a little more, like a little bit less smooth of a look. And then here, I'm actually using the Voronoi noise as holes, so I'm like, you can see right here, there's a giant chunk taken out of that. And then I'm sending that to, this is the normal ambient occlusion depth map generator in the other materials. This is just what it looks like when it's not grouped together into one node. Next up is the other rock texture, which is more of like an iron rock. So what I do here is I'm generating Voronoi noise, and then I'm making it so that there's only two colors that the cells can be, which means that like the entire image is divided into two separate parts, which will be separated by borders, so that I get nice edges from that. And then I'm just generating some noise to pick out some random edges from there, and I'm using those as like the large scale features of the rock. And then I'm dilating to smooth that out. I'm warping to make it look more natural. Up here, I am just kind of taking that large scale texture and I'm tiling it across the entire image. So that way there's a bunch of like small scale versions of the one big scale thing. Because it's rotated around and stuff, it doesn't look the same. And then I'm coloring that, and I'm generating a more of like a rust color up here. And so the idea is that the large scale patterns are colored one way, and the smaller scale patterns are colored a different way, so that they create this nice blend effect. Also, if you look here, I'm making it so that these smaller scale ones have an effect on the height map, but less of an effect on the height map, and then running through the NOD node just like before. The last one up is the Apache Grass one. So down here, I'm just generating a bunch of leaves coming from the same point. Then up here, I'm generating a bunch of rocks, and I'm tying them around to get a lot of rocks. So this is just like a nice detailing effect. This here is there's just like the default ground, then I add the rocks here. Right here I've added the grass. I wanted it to be a little bit smoother on the grass, kind of like I was going for like a dew effect. So if you look at it from the right angle, it's kind of shiny. I want like the inside of a blade of grass to be a slightly different color than the outside. So that's what I'm doing here. I'm selecting the inside and then I'm coloring the inside a lighter color there, and that should be all the textures. And then once we've created all those materials, what we do is we go up to File, Export Material, and we select Unity HDRP. And what this does is it will actually create the textures formatted for Unity, and it will even create a material that's already like connected to the textures that it creates. The only thing it doesn't do is like mess with any of the settings. So like for the leaf texture, I had to add double-sided and alpha cutout. And for like the height maps, I had to manually multiply to determine like exactly how much from the surface it can change its elevation. And this is what my scene looks like. As you can see, there's these small plants and there's these bigger trees. There's some rocks scattered around, and there's a grassy landscape. I like it. Now, if you pay attention to the scene view, you'll notice that I've got these spheres instead of the actual trees. And the reason that's the case is because I'm actually procedurally generating the meshes for all of the plants in when I hit play. Each plant is an L system, and that leads you to wonder what an L system is. So an L system is basically a context-free grammar that sort of like describes what the plant can be. And then you iteratively replace the non-terminal symbols with what it could be made out of. It's like the right side of the production. And turns out if you do that repeatedly, you get like these nice recursive structures, and plants tend to be very recursive. So I did that, and then I run that iteration like between like 6 and 8 times, depending on like the actual size of the plant. You can see right here's the code for one of the bigger trees. So these commands that are continue and branch and RG. RG stands for rotate golden, because plants naturally branch out in spirals. And if you pay attention to what the like rotations are of those spirals, the golden ratio is a very common one. It's pretty irrational. It generates not a lot of overlap, and that's ideal for what plants want. That's the L system part. The other part is the tree interpreter. And what that does is it converts so the output of an L system will be just a string, and the tree interpreter will take that string, and then it will interpret those tokens to generate the mesh. It uses a stack system, so whenever there's a parentheses here, well, it pushes an element on a stack when there's an open parentheses. It pops an element off the stack when there's a closed parentheses. So, like, if you want to branch, you'll always push an element on the stack so you can come back to that and continue building the rest of the tree that you branched off of. That's the idea. All these sliders are a bunch of parameters to control, like, exactly how those commands are interpreted. And there's a bunch of randomness in the exact directions you go and the like exact thickness of the tree. That's so it looks a lot more natural. It looks pretty decent even without it, but it looks like when you add randomness, I think it really takes it to like a whole new level. Let me just show some code. So this is the Lexer. It's used for both the tree interpreter and the L system. The L system uses this to iteratively replace the tokens with the right side of the production. The way the meshes are generated, there is two meshes for every plant. There's the stem and then there's the leaf. The leaf submesh is entirely made out of billboards with double-sided textures. The stem, it's kind of like a cylinder. It's a way to think about how it's mapped, but it's like a pretty low poly cylinder. It's just like a cube. But the way the normals are generated automatically by Unity, it makes it look more like a cylinder. So that's cool.